Might have to make 2 bits. Hey, Jack, how much pull you got on that?
a big day.
Lines away.
Lines away. Forward lines off.
Forward lines off.
Yeah. That way everybody. Yeah. These chairs.
We're going to see how well Bart leads him.
A Nimitz class aircraft carrier uses steam-powered catapults to quickly launch aircraft to the speed needed for flight. Steam catapults use high-pressure steam to drive pistons, which in turn move a shuttle mechanism that launches the aircraft. Catapult-assisted takeoff makes it possible to launch heavier strike aircraft carrying full fuel and weapons loads. The Queen Elizabeth class aircraft carrier operates short takeoff and vertical landing aircraft with the help of SkiJump ramps. SkiJump ramps give an upward boost that helps aircraft such as the F-35B. Lightning II during takeoff. The Queen Elizabeth class aircraft carrier is equipped with a distinctive SkiJump ramp than using catapult launch systems. The F-35B Lightning II enters short takeoff mode by engaging its lift fan and directing its exhaust nozzle downward. The SkiJump ramp gives the aircraft an upward trajectory, enhancing its initial climb performance. The lift fan helps shorten the takeoff distance. Compared to conventional fighter aircraft, integrated deck management systems coordinate fueling, arming, and aircraft positioning in an efficient sequence. Releasing the brakes starts rapid. Acceleration along the short flight deck toward the SkiJump ramp. Deck crews give final signals after confirming control surfaces. Lift fan doors and nozzle settings are correctly configured. The ship's forward speed produces strong wind over the deck, which increases the aerodynamic lift generated by the aircraft. As the aircraft reaches the ramp, its nose gradually rises, following the upward slope. The lift fan helps shorten the takeoff distance compared to conventional fixed-wing jets. During landing, pilots slowly reduce airspeed while lining up with the designated landing area on the deck. When conversion mode is selected, flight control systems switch to settings optimized for vertical flight operations. The rear exhaust nozzle pivots downward to balance thrust between the forward and rear lift sources. Advanced flight control computers automatically maintain stability and pitch, roll, and yaw during transition. USMC ordnance teams arrange munitions on the LHD flight deck while adhering to strict safety procedures. Weapons are checked to confirm the condition of fuses, guidance kits, and suspension lugs before they are loaded. Hydraulic lifting equipment is used to position bombs and missiles under the appropriate wing pylons. For lighter munitions, personnel can often manually lift and attach them more quickly to the wing pylons. United States Marine Corps pilots set up the Harrier jump, jet for short takeoff operations at sea. Flight deck control verifies wind direction, ship speed, and adequate spacing between aircraft for safe operations. The pilot chooses the short takeoff setup, adjusting the nozzle angle to balance thrust. Airflow created by the ship's motion over the deck improves aerodynamic lift as the aircraft accelerates. Sorties often carry high explosive bombs to meet operational payload requirements and maintain aerodynamic efficiency. Attack profiles can involve shallow dives, level release, or pop-up delivery methods. Harrier pilots join the ship's recovery pattern, aligning with the deck heading before performing a vertical landing. Pilots use fine throttle and control stick inputs to keep the aircraft steadily positioned in a hover just before landing. The Bell Boeing V-22 Osprey is a tiltrotor aircraft that merges helicopter style vertical lift with the speed of a fixed-wing airplane. Twin proprotors on rotating nacelles enable the aircraft to switch between hovering and forward flight modes. Flight control computers help maintain automatic stability while the aircraft transitions between modes and hovers. The descent rate is carefully managed to ensure a smooth touchdown on the reinforced deck markings. LPD deck crews are on standby to secure the Bell Boeing V-22 Osprey to the flight deck using tie-down chains. Underway landings showcase expeditionary mobility and the ability to quickly insert forces from the sea. Forklifts transport cargo to the rear ramp of the Bell Boeing V-22 Osprey, where pallets are then rolled inside along built-in rollers. After loading the cargo, the Bell Boeing V-22 Osprey is prepared for departure to transport its load to shore. Deck crews remove the wheel chocks and tie-down chains, with the clearance confirmed by the pilot. In a vertical takeoff, the aircraft ascends straight up while maintaining stable hover control before transitioning into forward flight. External parts such as rudders, diving planes, sonar domes, and propulsors are carefully removed using cranes. Salvage teams use oxyacetylene torches, plasma cutters, and hydraulic saws to carry out accurate cutting operations. Cutting usually begins at the aft and forward areas, working toward the center to separate the reactor compartment and other critical systems. Radiation monitoring. Instruments are used throughout all cutting operations. When working near the reactor, or areas that were previously exposed to radiation. Before cutting the hull, crews first strip out internal components such as control panels, piping, electrical wiring, and bulkheads. The reactor compartment is sealed, lifted out with heavy cranes, and then placed onto specialized transport for shipment. Hull sections are lifted using gantry cranes and then transferred onto transport vehicles for recycling or additional processing. Sensitive systems such as fire control, computers, and sonar electronics are either destroyed or handed back to Navy control. Materials like high-strength steel, copper wiring, and aluminum fittings are separated, cleaned of contaminants, and prepared for recycling. Environmental control systems manage air filtration, contain debris, and ensure the safe handling of any hazardous waste generated.